The question says that the sum of the zeros of a polynomial is this, is 1. That means we are given the sum of the zeros. As you know, sum of the zeros are indicated by alpha plus beta. And that is equal to 1 given. And we have to find the value of k. Now, first of all, we are going to write this equation in the standard form, which is, by comparing this equation with the standard form. By standard form, I mean to say that by comparing this equation from ax square plus bx plus c, what you can see that this is a. That means the coefficient of x square is a. We have a as k square minus 14. Then b, which is the coefficient of x, which is minus 2 here. And c, which is the constant term. And we can see that the constant term is c, which is minus 12. If you look into the constant term, it is minus 12. Now we are given the sum of the zeros, and what do we know that the sum of the zeros is indicated by the formula minus b by a. Minus b by a is equal to 1. I substituted alpha plus beta as sum of the zeros, which is minus b by a. Now replacing b from here, which is minus 2. So minus of minus 2 is plus 2. And a, which is k square minus 14. This is k square minus 14 is equal to 1. Now, what we will do next is do cross multiplication to get the value of k. So it's k square minus 14 is equal to 2. Therefore, k square is equal to 16. That implies k is equal to plus minus 4. Remember, we are finding the square root of 16, and k can take positive or negative values, but must not declare the value of k without verifying that you know that a quadratic polynomial, which is ax square plus bx plus c is equal to 0, where a should not be 0. So you need to cross check, is any values of k is making this a as 0. I can see whether I place k as 4 or minus 4, I'm getting 16 here, and 16 minus 14 is not 0. So in case if you get 0, then you have to discard some values of k, which is not. Therefore, we say that k is equal to plus minus 4 is the final answer. So we'll be writing k can take two values here. That is k is equal to 4 or k is equal to minus 4. Both is true.